Even study hall is bad.
What are you doing in the hallway?
One right in the highlighter.
You're just
Getting
Yeah, like all that kind of question.
right there.
How dare you get books?
Yeah,
You trying to learn?
Alright, so like
Who do you
for the
think you are?
next week or so, I just have some like loose ends. This is not going to feel fluid at all. It's just going to be kind of jumpy. So we did the integration by parts and kind of wrapped that up with that worksheet, and now I can do like just some topics that could show up on the test as multiple choice questions, nothing that's like a huge deal. Pretty easy if you just know what to do. So there's this little section about finding the length of an arc. So like, you know, if I had this graph or whatever, you can actually use integration to find out like how long this like arc is. If you think about it, there is no way to find out what that is other than like, I don't know, somehow graphing it on like an axis that is like feet by like one, you know, square feet or whatever, and then like drawing the graph and then measuring the piece of string and how long. So that'd be like a really long process. So there's an actual way to figure out how long one little piece of arc is. It's not similar to circumference, but it's kind of like if it was a circle, I have a formula for that. It's 2 pi r. But if it's not a circle, or a section of a circle, I don't have any formula for that. So, if I'm trying to figure out how long this arc is, we kind of think about this as a triangle in a way. And I want to think about like, if I could zoom in and think about the minuscule part of that arc. So I'm not actually thinking about like the picture and the size that it is, but if I could make it like as small as I can imagine, I can call the change from like one point to another, I can call this change a change in x, and dx would be a great way to represent that because that's what a derivative is, it's a change. So dx is a good way to represent the change in x, and therefore this would be the change in y. So if I wanted to find out how long this arc is, and I know this isn't a right triangle, but if I zoomed in far enough, this would basically be a straight line. If I kind of think about it in the infinitesimally small scale, and then I just kind of apply it to a grander scale, how could I represent that third side? Using what? Instead of that, I could use Pythagorean theorem if I think about the concept of zooming in so far on this, that this curve actually kind of flattens out, and looking at such a small little part, that I can represent this curve with the Pythagorean theorem. So, it would be the square root of dx squared plus dy squared. Does that make sense? Well, if that's like one insanely tiny, tiny part, so if that's actually just like, that's like this little tiny part is what I can't even imagine how small that is. If I want to find the length of that arc, I can actually just integrate from a to b that thing. I'm basically taking that little distance, which isn't big at all. It's as tiny as I can imagine. And I'm going to add up an infinite number of them on this interval from a to b. It's the same thing you do when you rotated an arc. We took the area of one of these circles and we added up an infinite number of areas so that we kind of like had the volume by adding up a bunch of areas. Now we're basically adding up a bunch of little tiny segments, adding them all up from a to b so we have the entire thing. That is not the formula we're going to use because it's not in a user-friendly format. So this isn't what you need to memorize. I'll show you what you do. To algebraically manipulate this, I want to factor a dx squared out of here, which seems to make no sense, but it will in a minute. If I factor out a dx squared, what would I have in place of a dx squared if I'm going to factor it out?
1 plus dy.
1. And what about here, a dy squared? If I want to take a dy out, what would I be, or, I'm sorry, if I want to take dx squared out, what would I be left with?
1.
Think about, like, if I had, sorry, how do I want to say this? 2 plus 1/3. And I want to factor out a 2. I'd have 1 plus what? What would I have left in place of 1/3?
That divided.
Like, how I think about it is if I want to take a 2 out of a 1/3, I can multiply the top and bottom by 2. And I'm going to take this 2 out. I have left 1/6. Does that make any sense? So if I want to take a dx out, and I have no dx, I'm going to multiply this by a dx squared over a dx squared. So if I take this dx out to the front, I have left dy over dx. And they're both squared. The whole thing is squared. If that doesn't make sense, don't really worry about it. But what I get in the end is this. If I have a square root of a dx squared, that can come out. And it's just what? It's just dx. So to find the arc length from one left point to another left point, it's going to be the square root of the second derivative of y with respect to x dx. Algebraically, it's just like a pain in the neck. It doesn't really matter. Completely understanding it, what you need to know is this. This is the formula to find arc length. So real simply, what we're going to do is, if we want to find the length of an arc of some function, we're just going to use this formula. What we're going to do is we'll take the function, take the derivative of it. Actually, sorry, I don't mean the second derivative. I mean the whole thing squared. Sorry, we're going to take the derivative of it, square it, and plug it into this formula. So it's as simple as this. Let's find the length of cosine x. Haven't you ever wondered? I'd say sine x, actually.
I'd say no.
Haven't you ever wondered how big one hump of sine is?
Yeah.
What would we go to? 0 to what?
Pi.
Yeah. Always wondered how long the sine is. So let's find the length of sine from x equals 0 to pi. So all we got to do is, step 1, find dy dx. So if y equals sine x, the derivative is
Cosine x.
Cosine x. Second step is square that. And plug it all in. So the length of that arc will be from 0 to pi of the square root of 1 plus cosine squared now, is there any way to do that easily?
With my calculator.
Isn't there a substitution?
Yeah, that's
Isn't there?
Well, so let's see. If I want to do that by hand, is 1 plus cosine squared Pythagorean triple or not?
Almost.
It's almost. It's got to be 1 minus. The triple goes like sine squared plus cosine squared equals 1. So to get it to be 1 plus cosine, it'd have to be negative, and it's not going to work. So it's not one of the special ones. There's no way to do it other than using your calculator. So most of the time, like 97% of the time, you can't do it by hand. It's going to be a calculator problem. So using your calc, do I have the answer? No. I actually did it from 0 to 2 pi, so it should be just half of that. So see what you get.
It's not 3. It's not 3.
It's 24.
I hope so. I heard grammar parentheses is squared.
That's not 34.
You're right, it is. Squaring cosine is so annoying.
No, the parentheses part.
That's what I mean, like, right, how to... What?
What
It's
is your
4.
problem?
I was close.
Did you get 3.8 something maybe?
I have 4.4.
Really?
4, 1, 7, 7, 0, 2, 4, 6.
There's 24.
You're in radians?
Actually, I don't know if I'm being degrees. Yeah, I'm in degrees.
3.82.
Okay. Because I have 7.6 as like from 0 to 2 pi, so.
So many parentheses, I can't handle
Don't
it.
forget 3 decimals, 3.8 what?
2, 0.
Yay.
Do I have to put the 0?
Why not? No, they're not gonna take off if it's a 0, but why not?
Put a 1.
Like
If I put like any number in for the 0, would they count it wrong?
Yes.
Jesus Christ, there's a lot of things. Especially black.
Okay, any questions so
Should
far?
probably-
Pretty simple concept. The only annoying part is just knowing the formula.
Did-
But
the
there
calculator's
are a
so old.
couple of things to watch out for. Problems.
Enjoyed it.
I'll do that.
And then I lost it. Goes back to class.
Watch out,
Oh,
not
you
fair.
Right.
Looks like I'm getting up good.
So the places where you can have problems,
Corners.
corners and cusps.
Those blasted things.
Those blasted corners and cusps. So let's look first. If you think about something easy, what's the first like easy corner problem that you
Absolute
think of?
value.
Absolute value of x. So let's find the length of y equals the absolute value of x. From x equals -1 to 1. Now here's the thing. If you try to put this in your calculator, you can't, first of all. In fact, if you tried to like find the area, even if you had tried to integrate like the area of the absolute value of x dx from like -1 to 1, it won't let you. It's gonna say problem, I don't know, like error vertical tangent line or whatever. Like I think because it's not differentiable at that corner, it's gonna have a problem. So you have a couple options. For this one, because it's simple enough, you can split this into 2 separate parts and do this part and this part, or why even use the arc length formula? How else could you find out the distance?
Triangle.
Just be like 2 and 2.
Yeah, couldn't we just know, like, can you figure out this side of it? Because this is 1 and this is 1, so this is the square root of 1 plus 1, this is root 2, and this is also root 2.
Jeez.
So it's 2 root 2. So you could try to just figure it out if it's something that's that simple by using the Pythagorean theorem. But it's probably not going to be simple. So here's a not simple one. Yeah. Remember in pre-cal when we rewrote crazy absolute values as piecewise functions?
Yeah.
Sort of, but not really.
So you're going to have to do that.
Oh.
Yeah. So there was actually a point in doing that. It just doesn't happen real often. So where is this going to have its problem? The problem's going to be at x equals what?
0.
And I know that just because that's what makes the absolute value 0. If I had had x plus 4 inside the bars, then -4 would be the place where I have a problem. So what that tells me is I'm going to have to integrate from, -4 to 0, and then add on from 0 to 4. So I'm going to have to split this problem up at 0. Well, to split it up, I need a derivative of a function. But I don't have the function yet. I've got it in this weird form. So I'm going to have to rewrite the function. As a piecewise. So, do you remember what we do?
Well, you plug in something less than it, something greater than it.
Exactly. Plug in something less than it and something greater than it. And if when you plug the thing in, it doesn't change the sign of the absolute value of what's inside, you leave the problem as is. So for example, if I plug in 1, that doesn't change the sign, like, it doesn't make that negative, it keeps it positive, I guess I could say. So I'm going to rewrite the problem without the bars, replace the bars with parentheses, or in this case, just multiply them out, and it stays like this. So when I plug in something bigger than 0 and it doesn't change the sign, or it gives me a positive number inside the absolute value bars, I keep everything as is. When I pick a number less than 0, it gives me a negative inside the absolute value bars. All that means is the sign in front of the absolute value bars changes. Only that sign, not all of the signs. So I'm going to have x squared, and instead of minus, I'm going to have plus 4x. But it's going to still stay minus x. If I just simplify this a bit, x squared minus 5x, and x squared plus 3x. Any questions so far? How I got that? I am filming it too, just so you know, so if you want to look back at the section, you could. Okay, so this is y equals, well, I don't need that for the formula, I need dy dx. So I can go take the derivative of each of them separately. So when x is less than 0, the derivative is going to be 2x plus 3. And when x is greater than 0, the derivative will be 2x minus 5. So now I'm going to follow the formula and put them into their pieces back over here. So when x was less than 0, I'm with this piece. I'm going to use the square root of 1. It was plus, right? dy dx squared, so it's 2x plus 3. And then the other formula, same thing, but the dy dx is different. That's fun. So bless you.
Thank you.
Alright, I don't, oh sorry, go ahead.
You just plug that in your calculator.
Plug it in, yep. So you put in the 1, like FNINT or whatever yours comes up at, finish it, plus do another one. I think I got the answer on mine as 19.56. In case you want to go try it. Okay, there's one other problem, but I don't think it's going to come up, so I don't think we're going to worry about it.
Cool.
Okay. Homework tonight is actually, I'm going to stop here, is worksheet.